ఉన్నాను స్టార్ట్ చేయమంటారా? ఓకే. గుడ్ మార్నింగ్ మై డియర్ స్టూడెంట్స్. Today we are going to take up the class on consolidation of soils. Consolidation of soils. So last class we have seen the chapter on compaction. In that class we have observed all the differences between compaction and also consolidation process. And as you know, both consolidation and compaction is the process of reduction of volume of the soil mass, but in different means. In case of compaction of soil, it is achieved by means of expulsion of air from the soil. Whereas in case of consolidation, it is reduction of volume of the soil by means of expulsion of the pore water. Just look at the definition: consolidation of soils, process of reduction in volume of soil by the expulsion of pore water due to the application of sustained load. So here the load is always sustained load, static load, and pore water will be expelled from the soil over a long period of time. So that means consolidation will take long period of time to achieve some degree of consolidation depending upon the type of soil and other parameters. Whereas in case of compaction, we are going to apply dynamic load, not sustained load. We are going to apply dynamic load, and there the process is expulsion of the air voids. You can look at the two diagrams. The left diagram is compaction of soil. So initially the soil consists of three constituents: solids, water and air. And in case of it is the process for compaction of the soil. So out of all these three constituents present in the soil, by means of mechanical application of the energy to the soil, energy imported onto the soil, the air is expelled from the soil. You can look at initially the volume of the soil consists of solids, water and air. And after compaction, after applying compactive effort onto the soil, the volume gets reduced. What type of volume reduced? The solids will be the same as that of initial. The water content also same as that of initial. That means water not content, volume of the water is also same, volume of solids also same. Only the change is decrease in the volume of the air. Because of the decrease in the volume of the air, that is expulsion of air, the total volume of the soil mass reduced. So originally initial height of the soil is reduced to some certain height by expulsion of the air. So this is the process of compaction. So in the process of compaction, there is no change in solids, there is no change in water volume, and only the change is volume of the air. Whereas in case of consolidation process is always for the fine grained soils, particularly the clay soils. Consolidation will occur only in clay soils, and before consolidation, the soil consists of only two constituents or two-phase diagram. So the soil consists of solids and also water, and this is the total volume of the soil mass just before the consolidation. And after consolidation, some amount of water expelled from the soil and volume gets reduced. You can look at here in these two diagrams, the volume of the solids remains the same, there is no change in it, but the volume of the water reduces to certain extent depending upon the time period and also the pressure applied on the soil. So it is expulsion of water. So you can clearly understand the difference between compaction of the soil and also consolidation of the soil. In the case of consolidation of the soil must be completely saturated. There is no air present in the soil, and only pore water will expelled from the soil, and some part of water also remaining. And after compaction, the soil gets reduced. Volume of the soil gets reduced. So this is the overall concept behind the consolidation process. So in the consolidation process, two things are important. One is the load is sustained load. Always load acting on the soil is sustained, static load. And the expulsion of pore water takes place, and the soil must be fully saturated in condition. So these are the three important points during the process of consolidation. Now let us look at the diagram, types of consolidation. So you can look at the diagram. One y-axis is a settlement and x-axis is time. So once the soil is subjected to some static load, and over a period of time, it is going the soil is going to settle down. Volume of the soil is going to reduces, and it follows a curve. You can see the red line. You can see the red line. So that means initially the settlement will be almost zero at the initial stage, and as the time passes, at the time t equal to 0, settlement is 0, and afterwards that means afterwards it is going to increase the settlement as it is going to as time increases. So this is the overall view of the relation between the time and also the settlement for any consolidated soil. But in the process of consolidation, there are three different types of consolidation. One is initial compression. What is going to happen is initially sometimes the soil may not be fully saturated. If the soil is not fully saturated and if there is a small amount of air present in it, and because of some initial static load, it is going to compress by expelling the air, or sometimes the surface of the soil may not be uniform, and after keeping the static load on it, the surface of the soil will be leveled, so that the initial compression is the settlement due to initial problems. That means due to by keeping uneven by from the soil changing from unevenness to the evenness, or otherwise a small amount of air pockets present at the top, that will be removed by means of the initially applied load, and that compression is called the initial compression or initial settlement. And another settlement is primary settlement. Primary settlement is the major part of the settlement that you can look in the graph, major part of the settlement, and it will take several years. Sometimes it may be months, years, or hundreds of years, thousands of years also, depending upon the magnitude of the sustained load acting on the soil, and it is the major part. More than 90% of the total compression is by means of the primary consolidation only. And in this particular process, expulsion of pore water for a long period of time will take place, and more than 90% of consolidation because of the only primary consolidation. So next, another one is secondary consolidation. You can look at secondary compression or secondary consolidation, and the magnitude of the secondary consolidation is very small, and that is possible only when the rearrangement of soil particles takes place and entire soil is in the plastic condition, and all the particles are surrounded by the fluid, so that the soil particles will become more plastic in nature, and the soil is also completely ductile in nature, and viscosity of the particles around the particles also more. So at the secondary compression, the rearrangement of soil takes place, and the entire soil is in plastic condition, and the deformation during the secondary consolidation is called the secondary compression. So the total compression of the soil consists of maximum settlement. We can call it as total settlement of the soil is maximum settlement. This maximum settlement is always fixed. For a given soil, maximum settlement is fixed. So maximum settlement from to soil is different. Maximum settlement from soil to soil is different. But for a given particular soil, the maximum settlement is constant. But only thing is, sometimes we can achieve the maximum settlement with a less amount of time by means of several other methods. By the application of the extra additional overburden, we can reduce the time, or by some other several methods by providing sand layers in between drainage paths, so that we can reduce the time of the consolidation. But maximum settlement is always constant. Maximum settlement does not depend on the magnitude of the loading and also the rate of loading. It does not depend on the rate of loading and also magnitude of the loading. But the time lag, you can see the secondary settlement will occur at this much time. That time can be reduced by applying several other methods that we can look little later. So these are the three different types of consolidation for reducing the volume of the soil. And you can also see the total settlement. The total settlement is initial compression, primary compression, and also the secondary settlement. Total settlement for a given soil is constant. It does not depend on the rate of loading and also the rate of settlement. It is always constant for a given soil. And we can compare the entire consolidation process by means of the spring analogy. So we can, Tarjagi demonstrated the mechanics of consolidation by means of piston and spring arrangement. You can look at in the first diagram. So this is the piston and also spring arrangement. So this spring is nothing but the soil particles in the soil, and fluid in the piston is nothing but the water particles or water is present in the soil. So initially, when the static load is applied, W is applied, and if there is a small opening, that opening also closed, then the entire load will be taken up by the soil particles and also the water. The entire static load is taken up by the soil and also the water. But water exerts some pressure. If that opening is removed, what is going to happen? The soil particles will get compacted. And at the same time, the fluid will move outside through the pores. That is called through the pores. You know that the main process is consolidation takes place by means of the pore fluid, pore pressure, the expulsion of the pore pressure. So here, by means of applying the static load, because of the pore pressure, the water is moving away from it and it gets compressed, or volume of the soil is going to reduce. And further allowing water from this, then it gets consolidated and volume reduced further. So we can compare this entire process of consolidation by means of the piston and spring arrangement. And this theory was demonstrated by Tarjagi. Normally in the laboratory, we can find out the compressibility characteristics by means of the odometer. Consolidation properties can be found by means of the odometer. So compressibility characteristics, including time rate of compression, everything can be found by means of odometer, and it was developed by Tarjagi. And application of the load is only the static load. Already I told you. And here the major process is expulsion of the water from the soil. Consolidometers are two basic different types. One is fixed ring type, another one is floating ring type. So here what is going to happen is a small soil sample of a specimen. Here overburden load, arrow mark shows that overburden load is acting on the soil mass, and how much load that is acting or what is the deformation of the soil takes place will be measured by means of the dial gauge, and surrounding it will be water bath, and top and bottom porous plates are being provided. So in case of a fixed ring type of consolidometer, what is going to happen is fixed ring means bottom porous stone, bottom arrangement is completely fixed. Only the top arrangement is moving. Only the top arrangement is moving. That means top porous plate is allowed to move so that the deformation obtained only from one side. Whereas another one is floating type of consolidometer. In this case, both bottom plate and also top porous plate both will move and compress the soil from the both the directions. So this is the only important thing to understand the types of consolidometers, and how the plates are moved, and what is the deformation taken place in case of fixed ring type and also floating type of consolidometers. Now let us go for analyzing the entire compression of the test data. So already in the first chapter you have seen delta E. You have seen delta E is proportional to delta H, because you know delta E means change in void ratio. Change in void ratio is nothing but the change in the thickness of the soil. Change in thickness of the soil. And H is initial height of the soil, which will be equal to 1 plus E. Already in the three-phase diagram we have shown total volume is 1 plus E. Total volume is nothing but 1 plus E. Total volume means it is nothing but H into area. Area is constant. So 1 plus E total volume is always proportional to the height. Already in the first chapter we have seen this particular formula. Change in thickness of the soil by original thickness will be equal to change in void ratio divided by original volume. 1 plus E is nothing but the original volume. So from this you can find out the change in void ratio delta E or any other parameter. You know delta E means E1 minus E2 or E0 minus E1. Out of all these four unknowns, you can find out any of the unknowns. So that means the height of the soil reduced by delta H, and the total volume 1 plus E is nothing but the total volume of soil mass. 1 plus E total volume is reduced to delta E, and this can be related. And while analyzing it, if you plot a graph, because the application of the load on the soil in the laboratory test is always compressive, and if you draw a graph between a compression and time, and the graph will always vary with reference to the magnitude of the stress applied. Say for example, in this case it is a generalized one. You can look at one is a dial gauge reading compression. So normally the load acting on the soil mass is measured by means of the dial gauge reading, and accordingly converted to the actual value of the load, and the same will be presented on the y-axis, and other axis time. So as the time goes on increasing, the compression of the soil also increases. Compression of the soil also increases, and it is final compression. It follows a curve. So this is here what we do is in the laboratory we are going to keep the stress acting on it will be constant. Constant compression, constant sustained load will be placed on the soil. So the stress acting on the soil is constant. For a given stress, compression varies with the time. Compression varies with the time. So here you can look at, so we can apply different magnitudes of the stresses. You can look at here. The first curve represents when the soil mass is under a pressure of sigma 1 bar, under effective stress of sigma 1. When soil mass is subjected to sigma 1, it follows some curve. And afterwards, the load increases or stress increases on the soil mass, then it takes another path. It takes another path. Again, at some other level, at some other time, you can also increase the stress on the soil mass. It follows another path. So each and every increment of the stress, each and every variable of the stress, it has its own curve for compression of the soil mass. Compression of the soil mass. And there are some few small definitions that you need to understand clearly so that any numerical problem can be solved by means of understanding the total concept in consolidation chapter. So first important definition is coefficient of compressibility. Coefficient of compressibility. It is represented by AV. Coefficient of compressibility represented by AV, and this is the slope of the E sigma dashed curve. That means if a curve is drawn between the void ratio and the pressure, void ratio and pressure, the slope of that curve is called the coefficient of compressibility. So you can look at the second diagram. You look at the second diagram. On y-axis, E values, void ratio values. On x-axis, the various pressure acting on the soil mass, the sigma value. X-axis represents the effective stress. Y-axis represents the void ratio, and a curve will be obtained with the shown in red. Shown in red. So at any particular point, if the tangent is drawn, the slope of that tangent is nothing but AV. Slope of that tangent is AV. So you need to remember the overall concept so that you never forget this. So don't remember straight away AV equal to delta E by delta sigma dash. If you just remember straight away the formula, you may not get the same formula at the appropriate time where it is required for the examination. But that's why you always understand that it is a graph plotted between void ratio and the stress, and the slope at any point is nothing but the coefficient of compressibility. So what is the slope here? Slope means vertical ordinate. What is vertical ordinate? E1 minus E2. E1 minus E2 is nothing but delta E. E1 minus E2 is nothing but delta E. And what is the horizontal distance? It is nothing but sigma 2 minus sigma 1. When a sigma 2 minus sigma 1 is nothing but the change of effective stress delta sigma dash. So AV equal to delta E by delta sigma dash. So that can be understand very clearly from the diagram. So knowing the overall concept, you try to understand the formula. Don't simply by heart the formula, and that is very difficult to get whenever it is required. So here there is a negative sign in AV. In AV there is a minus sign. Why minus sign? Why minus sign? When the pressure increases from sigma 1 to sigma 2, when the pressure increases from sigma 1 to sigma 2, void ratio decreases from E1 to E2. So that means one parameter is increasing, other parameter is decreasing. So that's why it is called minus 1, minus the sign. So when sigma value increases, void ratio decreases. So that's why minus symbol is used in the AV equation. Okay, and again, if you plot the coefficient of compressibility on y-axis AV, coefficient of compressibility on y-axis AV, and effective stress on x-axis, it follows a curve like this. It follows a curve. So this is one definition. Next, compression index CC. Compression index. So compression index is the slope of the compression curve. And you know, when the load is applied, naturally, when the load is applied on a soil mass, compression takes place. And compression curve is plotted between E and log sigma. Between E and log sigma. In previous case, AV is nothing but delta E by delta sigma, and it is a curve. It is a curve. And at any point we can draw the tangent. At that point it is AV. And if I draw the tangent at some other point, the slope is different. If I draw one more point, one more tangent at other point, it is also different. That means AV is different for different sigma values. AV is different for different sigma values. It is directly plot between void ratio and the pressure, intensity of the pressure. Whereas in this case, for computing the compression index, it is also slope of the compression curve, but that compression curve is plotted for void ratio and log stress. In earlier case, void ratio and sigma only. Now, it is a plot between void ratio and log of sigma. So when you plot the graph between E and log sigma, it will be given a straight line. You can observe the total compression curve. So originally at 1.2, when the load is applied, it is going to reduce the void ratio and reaches to certain level. And if you remove the load, it is going to take the shape like this. It is going to take the shape like this. That is called the and removal of it is rebounded curve. And again it reaches to some 0.8. Need not be 0.8, any point. So the void ratio is decreasing continuously from a maximum level 1.2 to the void ratio is decreasing from that level, and initially it follows the curve, and afterwards it is a straight line. And reaching to certain level, and on removal of the load, it will be in recompression curve or rebounded curve. Again, if you reload it, it is going to take the shape like this and reaches to the original. So the original curve which has the straight portion is called the virgin compression curve. Virgin compression curve. And after removal of the load, the curve take the path as rebounded curve. And after reaching certain level, again loading, because of loading, again it is going to compress and recompressed curve. So virgin curve, rebound curve, again recompressed curve. So here CC means slope of the virgin compressive curve. Slope of the original compression curve. So this will become a straight line when you plot on log scale on x-axis, void ratio on other side. So in this particular case, what is the slope? CC is nothing but, CC is nothing but, what is the slope? Vertical ordinate. What is vertical ordinate? E. So E naught minus E divided by log of sigma 1 minus sigma 2. Log of sigma 1 minus sigma 2 means log of sigma by sigma naught. So initial void ratio, initial pressure, and final void ratio final pressure. So this is the relation. This Cc is called the compression index, which is the slope of the virgin compression curve. Slope of the virgin compression curve. So from this, you can also write the final void ratio. E naught is the initial void ratio, E is the final void ratio, E equal to E naught plus minus this. So from this equation, you can also write in that way. So don't try to by heart the equation. You also understand Cc is the slope of the curve. So y-axis is the difference of the void ratio. X-axis is the difference of the stress. But this stress difference is with the log mode. With the log mode. That's all about the compression index. Next one. And normally, this compression index depends on the type of soil and magnitude of the liquid limit. An empirical formula developed for finding the compression index, because always the diagram may not be drawn. So in such cases, depending upon the type of soil, that soil depends on the various contents of the fine material, and naturally it affects the liquid limit. So coefficient of compression index is related with the liquid limit. In general, Cc equal to 0.007 WL minus 10. So minus 10 means in the liquid limit x-axis, the curve started from 10. The curve started from 10. So that's why it is WL minus 10. It is an empirical equation. There is no logic behind it. And for consolidation of field deposits, Cc will be 0.009 WL minus 10. So the constant varies from 0.7 to 0.9. So remember this equation, because it is an empirical equation. You have to remember all empirical equation. Any equation based on the concept, you need to understand the total concept for writing that formula anytime. Next, there are three different types of soils. One is normally consolidated soil, and soil may be consolidated over, so it is called over consolidated soil. And another one is under consolidated soil. So these are the three different types of soils that the consolidation takes place. So here what is normally consolidated soil? Normally consolidated soil is a soil which has never been subjected to a pressure greater than the present existing pressure. So what is the meaning of it? The meaning of it will be, this is the soil, and existing pressure on the soil will be equal to say 100 kilonewton per meter square is the existing soil, and in the time history, the stress on it will be less than 100. So that means less than 100 kilonewton per meter square. It may be 70, 90, 80, 60, 50, like that. Any amount of stress may be acting on the soil, and the stress at the existing level is equal to 100. So this is the existing pressure on the soil, and in the history, the pressure must be less than the existing. Then such type of soils are called the normally consolidated soils. You can look at OCR. It is normally represented by OCR, some relation. Maximum effective stress to which the soil has been subjected in stress history. So that means in stress history means this month or this year, previous 2 years. Observe the different types of loads. Whatever the magnitude of the loads, all the loads must be less than or equal to existing. Then it is called the normally consolidated soil. So OCR is equal to load on the soil during stress history divided by existing stress. So here existing stress is always more. Existing stress is always more than the previously loaded stress. Such a type of soils are called the normally consolidated soils. Normally consolidated soils. So in the formula you can say that existing stress is 100 and previous all stress history 50, 60, 70, 80, 90, again several combinations, maximum is 90. So what is the OCR? OCR will be equal to 0.9. That means when the over consolidation ratio is less than or equal to 1, less than or equal to 1 or less than 1, say 0.9, such a type of soils are called the normally consolidated soils. That means existing pressure is more than the pressure acting on the soil in previous cases. In previous stress history, the stress acting on the soil is less than the present existing stress. That is the meaning of normally consolidated soil. Now look at the over consolidated soil. Over consolidated soil means it is just exactly opposite to the previous one. So exactly opposite to the previous one. For example, if the existing soil pressure is 100, existing soil pressure is 100, in the stress history, it may be 90, 120, 180, 160. So for example, in 1 year, maximum stress on the soil is 90. In another year, 180. In another year, 120. In another year, 160 or 140, etc. So these are the various values of the stresses acting on the soil. Various values of the soil, various values of the stresses acting on the soil mass. And we can call it as stress history. So in the entire stress history, what is the maximum value that is there in the stress history? 180. So what you do? 180 divided by 100, it is nothing but 1.8. When the over consolidation ratio OCR is more than 1, such a types of called over consolidated. It is a very simple meaning. Over consolidated means already soil is consolidated. Already soil is consolidated. Already soil is consolidated means the existing pressure is less than the previously acting pressure on the soil. You just simply understood the meaning of over consolidated soil. That means soil is already consolidated. When the soil is already consolidated means the existing pressure is less than the pressure acting on the soil already. Pressure acting on the soil already. So now that is the meaning of the over consolidated soils. I'll read the line once again. Over consolidated soil is a soil which has ever been subjected to pressure in excess of present overburden pressure. Then it is also called as pre-compressed pressure. Soil is also called pre-compressed soil. That means already compressed. Over consolidated means already consolidated. So it is called already compressed. So the soils are called the pre-compressed soils. Compressibility of soil in over consolidated condition is much less than that of the normally consolidated soil. So normally it is always represented by means of consolidation ratio, over consolidation ratio, OCR. And if the OCR value is more than 1, it is over consolidated soil. If the OCR value less than 1, normally consolidated soil, and one more soil is under consolidated. So you know the meaning of it, under consolidated. That means soil is not consolidated fully. Soil is not consolidated fully means then the soil now is going to consolidate. So under consolidated soil is called the under consolidated soil. So for example, land filled with the material landfill by recent material is not consolidated. It is going to consolidate as the time goes on. So you can look at all these with respect to over consolidation ratio. For over consolidation clays, OCR always more than one. Simply remember it. Over consolidated means already soil is consolidated. Already soil is consolidated, so it is greater than 1. And normally consolidated soil, it is less than or equal to 1. Under consolidated soil, it is always less than 1. And sometimes the soil may be heavily over consolidated. Heavily over consolidated, then OCR is always much more than 1. It may be sometimes 5, 10, 20 also. For heavily over consolidated clay. Okay. So there are three different types that you have seen now. Normally consolidated soil, which are now going to consolidate. Normally consolidated means which are now consolidated. That means which are now going to consolidate because of the present existing pressure. Over consolidated means already consolidated with the present stress acting on the soil is much less than the earlier one. So it is called the over consolidated soil. And under consolidated soil means it is just a recent fill and it is going to consolidate with the passage of time. Then time lags during the compression of clays. Normally, compression of clays takes place because of the two parameters. And one is hydrodynamic lag. That means time because of the expulsion of the pore water. Time because of the expulsion of the pore water, the soil is going to compress. That is called the hydrodynamic lag. And another one is viscous lag. When the soil is completely in plastic state and viscosity of the soil particles is more and all the soil particles are formed by means of a lubricant type of water, then such a soils are called the viscous soil and time taken for the deformation, because once the soil is in viscous state, the deformation of the soil takes place. That deformation is called the shear deformation. Because of the shear deformation, the soil is going to compress. So the time, the compression because of the viscous is called the viscous lag. The time required for expulsion of pore water from the soil is called the hydrodynamic lag. I'll go once again. The hydrodynamic lag means time required for escape of pore water pressure. Escape of pore water pressure. So how much time is required for escape of entire pore water pressure? Then that time is called the hydrodynamic lag. It normally depends on the coefficient of permeability, because coefficient of permeability is the flow or velocity of the water, pore water moving from one place to the other place, and it depends on the amount of voids present in it. So coefficient of permeability is more important. Lower the coefficient of permeability, it will take more time. If the coefficient of permeability is more, it will take less time to escape entire pore pressure. So return again, coefficient of permeability is inversely proportional to the hydrodynamic lag. So that means if the coefficient of permeability is low, the hydrodynamic lag is more. And another one is viscous lag or plastic lag. Viscous lag or plastic lag. Lag means it is time. It is time required for shear deformation or expulsion of double layer of water due to viscous nature. Because once the soil is in plastic state and a double layer of water is formed around the soil particles and entire soil is in the entire soil is in plastic state and deformation takes place and that deformation is shear deformation. So compression of the soil is because of the shear deformation. Okay, it is in here double layer of water is highly viscous and bonded well with the clay particles, and the time required for plastic lag will be more compared to the hydrodynamic lag. Then coefficient of volume compressibility. So already you have seen one coefficient AV. What is that AV? Coefficient of compressibility is AV. Now it is coefficient of volume compressibility. Earlier coefficient of compressibility, that is AV. Now it is coefficient of volume compressibility, it is MV. Coefficient of volume compressibility MV. So this is sometimes called as modulus of volume change, or coefficient of volume change. So whatever may be the term, it must contain the volume. Volume change, it may be coefficient, or it may be modulus, or it may be any other parameter. So volume, when the term volume exists, then that will be called MV. When there is no term volume, simply coefficient of compressibility, that is called AV. One should not confuse between AV and MV. Okay, so it is defined as change of volume of soil per unit initial volume due to increase in effective stress. So you can observe here MV equal to change of volume. Delta E is change of volume to its initial volume. 1 plus E is nothing but initial volume due to unit increase in effective stress, delta sigma. Delta sigma means sigma 1 minus sigma 2. So this is called the coefficient of volume compressibility. Already you know that AV, what is AV? Delta E by delta sigma. AV is delta E by delta sigma. Substitute here. So MV equal to AV by 1 plus E naught. So this is the relation between coefficient of compressibility and coefficient of volume compressibility. So you know delta E is nothing but change in void ratio, 1 plus E is nothing but initial volume, and when the soil is confined laterally, what is going to happen? Delta E is always proportional to delta H, because you know delta E means change in void ratio, which is again proportional to the change in thickness of the soil mass, and also E naught is always proportional to initial value. No, not E naught, it is 1 plus E naught. 1 plus E naught initial volume, 1 plus E naught initial volume is always proportional to H naught. Now look at all this, it is also continuation to the previous one. You know MV equal to, in previous case you can look at previous formula, delta E by 1 plus E. Delta E can be written as delta H. 1 plus E naught can be written as H naught. You can see MV equal to delta H by H naught into 1 by delta sigma. So that means the change in the thickness of the soil mass, delta H equal to MV H naught delta sigma. That can be found from the equation. Or otherwise delta H by H naught, you can see delta H by H naught is already you know delta E by 1 plus E naught. So from this normally SC means settlement and C refers to consolidation. Consolidation settlement is referred as SC, or otherwise we can call it as settlement of the total height of the soil delta H, which is equal to delta E by 1 plus E naught. You can look at delta H equal to delta E by 1 plus E naught multiplied by H naught. Already all these formulas you know at the first chapter. Now consolidation settlement, what is delta? What is the value of what is the value of it? Delta H is nothing, but what is MV? What is MV? You can observe here H naught. Okay, you can look at here H naught divided by 1 plus E naught into CC log 10 of sigma by sigma dash. So already you know the delta E value from the compression index. I will show you. I will go back and I will show you what is delta E. So you can look at here what is delta E. Delta E equal to E naught minus E. E naught minus E is delta E, which is equal to CC multiplied by log 10 sigma by sigma naught. So that means we are replacing this delta by CC into log of sigma by sigma naught. So this formula is going to be substituted at this place. You can look at CC delta E place CC into log 10 sigma by sigma naught and 1 plus E also there into H naught. So this you can write H naught CC by 1 plus E naught log 10. What is sigma dash? Sigma dash means existing pressure. What is the existing pressure? Initial pressure plus additional overburden or additional pressure. So initial plus the additional pressure divided by the initial pressure. So this is most important equation for computing the consolidation settlement. A consolidation settlement equal to H naught CC by 1 plus E naught log 10 of sigma naught plus delta sigma by sigma naught. Most important formula for from the point of view examination. You have to remember systematically regarding this. Okay. Now, Tertiary theory of one-dimensional analysis. Tertiary theory of one-dimensional analysis. So, Tertiary assumed several things for deriving some relation for consolidation purpose. Soil is homogeneous. Normally, soil never be perfectly homogeneous. It is assumed that it is homogeneous and KZ is independent of Z. All properties are same for the soil at any position, and soil is completely saturated. Soil grains and water are virtually incompressible. There is no compressibility. The compressibility is not taken place by the soil grains and also water. Behavior of soil mass in regard to expulsion of pore water is constant. So behavior may not change when soil present more water, when soil present less water. There is no change of behavior. Behavior of the soil mass is taken always constant. Compression is considered only one-dimensional because no lateral compression or lateral extension is allowed here. Darcy's law is valid. V is equal to Ki, and soil properties also constant. Soil properties may not vary. Pressure versus wide ratio relationship is ideal, and hydrodynamic alone is considered, and plastic lag is ignored. Because in the plastic lag, what is going to happen is the compression is because of the shear deformation of the soil, and the analysis of it will be very complicated, and the time required for it will be very small, very high, and magnitude of the compression due to plasticity of the soil is also very small and hence neglected. So these are the generalized assumptions. Sometimes the questions for engineering service examination, etc. The questions are like this: which of the following is not assumption considered by Tarjaki for one-dimensional analysis for consolidation? And out of all four options, only one option is not correct, and all the three options are correct. And in such case, you need to identify the appropriate assumption. And don't by heart these things, and try to understand each and every line, and that will keep you always. And we are not going for a derivation of the basic consolidation equation. This is the basic consolidation equation. So sometimes the question may be basic differential equation for consolidation is, that may be the question. So remember, dou u by dou t equal to Cv dou square u by dou z square. So this is u is pore water pressure, and u is dependent variable, whereas t and z are independent variables. So this equation is called the partial differential equation. Partial differential equation with two independent variables and one dependent variable. And by solving this equation, for solving this differential equation, you will get Cv equal to K by Mv gamma W. So, or otherwise you remember this. Or otherwise you remember this equation K equal to, or otherwise remember this equation in this form. Because if you want to remember the formulas differently, for example, Cv equal to K by M comma W, if you remember in this way, sometimes what is going to happen, Cv equal to Mv by K comma W or comma W by K Mv, like that several doubts may arise at the time of exam. So for that purpose, always remember K equal to Cv Mv gamma W without anything, and it is permeability, coefficient of permeability equal to Cv Mv gamma W. So then the confusion of understanding the formula will be less in this particular case. Okay, and here in the Cv formula, again you can also substitute Mv. You can also substitute. Once you know the basic equations, you can get any number of equations. What is MV? MV is nothing but AV by 1 plus E naught. So that equation can also be put in terms of AV also. Okay. So CV is the coefficient of consolidation. Coefficient of consolidation. The units are meter square per second or millimeter per second or centimeter per second. And the dimension for it is mm square means L square, and second means T minus. So this is the dimension of coefficient of variability, coefficient of consolidation. CV means coefficient of consolidation. And another important formula, time factor. Time factor TV equal to CV T by T square or H square. Sometimes we can call it as T or sometimes H. So H or D, it is called the length of the drainage path. Length of the drainage path, and that means while expelling the pore water, how much distance the water is traveling. How much distance the water is traveling before the drainage. So that is called the drainage path, and that length is called the length of the drainage path, which is equal to H. So also remember time factor equal to TV equal to CV T by H square, and we are not going for derivation of this particular formula. And for a given soil, coefficient of consolidation is always constant. For a given soil, coefficient of consolidation is always constant. And similarly, for a given drainage path, H is always constant. If the path is fixed, H is also fixed. If the path is different, H value is varies. So in this particular time factor, several parameters are there: TV, CV, T, H square. And if the drainage path is same, H is constant. There is no change in drainage path. And if the soil is constant, for a given soil, the coefficient of consolidation is same. So TV is proportional to small t. That is time factor, TV is proportional to small t. Small t means the time elapsed for the consolidation. Time elapsed from the start of the consolidation process. So here TV is proportional to small t. So in all these equations, you need to understand which parameter is constant, which parameter is variable, when it is constant, when it is variable. So CV is same for a given soil, H is same for a given drainage path. And normal evaluation of coefficient of consolidation CV by means of two different methods. One is square root of time fitting method, which is proposed by the Taylors, and it is called the Taylor's method. In this, 90% of the consolidation is to be completed. For finding the coefficient of consolidation, 90% of the consolidation must be over. So, already you have seen earlier, TV equal to CV T divided by H square. Instead of H square, it is always better use D square. So, it is the standard formula. TV, this is a standard formula that you can look at. Always try to remember this. The same thing, because without any confusion, TV equal to CV multiplied by T into CV T divided by D square. So here understand the various terminology. T90 means time required for 90% consolidation. 90 refers to 90% consolidation. Total consolidation is 100%. But for the total consolidation, it includes initial compression, primary consolidation, and also secondary consolidation. And it is very highly difficult to get 100% of the consolidation, and around 90% consolidation is all right, and remaining 10% of consolidation will take it's a lot of time, several thousands of years also sometimes. So T90, time required for 90% consolidation. Capital T90 means, capital T refers to time factor. Time factor for 90% consolidation. And D is a drainage path. Small d is the drainage path. In this drainage path, normally what we do is, H is the thickness of the soil layer we represent. H is the thickness of soil layer. And D is the drainage path. And if the water is coming out from the soil is by means of single drainage path, it will take D equal to H. And for a double drainage, D is equal to H by 2. So the meaning of it will be, you can look at here, this is a very hard stratum, and this is called the clay, saturated clay. The water particle at the bottom has to move to the top, and it will be moving out for a distance of drainage path equal to H. That is single drainage. The water is allowed to move only in one direction, whereas in other case, on the top of the clay layer, and also bottom of the clay layer is sand. When the sand is provided, then water particle can move towards sand, either towards upward, or the water can move downward. What is the maximum drainage path? Maximum drainage path will be D will be equal to H divided by 2, because this particle either can move upward or either can move to the downward to the sand. So the drainage path for the sand in case of double drainage, we can call it as one drainage top, another drainage at bottom. So that is called the double drainage. So in that case, D will be equal to H by 2, and in this process of double drainage, consolidation takes place quickly. Whereas in case of single drainage has to only in one direction, and the total drainage path will be equal to height of the soil. So now look at other points. For again here, for a given soil, CV is constant. So here only CV is constant. Only for a given soil, only CV is constant. Now how time will depends? Time is proportional to T and also D. You can look at time is proportional to T and D square because CV is constant. So you can write T2 by T1. That means for different values, T2 by T1 equal to T2 capital T2 by T1 and also D2 by D1 whole square. That means if you know the time of consolidation T1 for a time factor of T1, you can find out the time required for T2 time factor. So by means of such type of relations, you can find out the various unknown parameters using the time factor formula TV equal to CV T divided by T square. And again, for the same soil and same degree of saturation. Same soil means coefficient of consolidation is same. And same degree of consolidation means T is same. That I will tell you little later. Same degree of consolidation means T is also constant. In that case, if the relation will be reduced to this. And D equal to H by 2 if it is a double drainage, and D equal to H if it is single drainage. So from this, you can look at what is D1? D1 is the one refers to double drainage, two refers to single drainage. That means time required for single drainage, is 4 times the time required for the double drainage. So that means if water is allowed to pass in the two ways, then time required for the same amount of consolidation reduced by 4 times. So T1 equal to T2 by 4. Okay, I will read. For to undergo same degree of consolidation, time required for single drainage condition is 4 times time required for double drainage. So that means when the drainages provided are more, time required for the same amount of consolidation is less. The second method of computing CV is logarithm of time fitting method, which is proposed by Casagrande, and it is called Casagrande method. And here also the same thing. The relation is same, T equal to CVT by D square, but here the analysis is done for the 50% of the consolidation. When 100% of consolidation is total, and when the soil is compacted to 50%, then the corresponding value of CV is the coefficient of consolidation. So T50 means time for 50% consolidation, and capital T means time factor for 50% consolidation, and D naturally drainage path. And U dissipated excess pore pressure by initial excess pore pressure. So dissipated excess pore pressure means initially the pore pressure in the soil is Ui and minus U divided by Ui. So this is dissipated excess pore pressure. Excess pore pressure will be expelled the water divided by Ui. So here already I told you this T is called the time factor. And U is called the degree of consolidation. U is degree of consolidation. So you just remember the degree of the consolidation means you know S means settlement. S means settlement. SCF means final settlement. Final settlement or maximum settlement are one and the same. Settlement S means it can be any value. This settlement can be corresponding to 50% degree of consolidation, corresponding to 90% consolidation. Any value can vary. But here SF is always constant because it is the maximum value of the consolidation possible. So SF is maximum, but S is variable. So you can look at here. U equal to S by SF. U equal to SF. That means degree of consolidation. How much percentage is consolidated is represented by the degree of consolidated. SF is the maximum possible consolidation, and already S settlement there, S settlement, and it is final settlement. The ratio will be the degree of consolidation. And sometimes in the examination, if U1, U2, S1, S2 are unknowns, U1, U2, S1, S2, you can find out any of the unknown parameter from this. For example, for 20% degree of consolidation, settlement is 10 mm. For 40% consolidation, what is the settlement? So that may be the simple question by means of this relation. And already you know that TV equal to CVT by T square. For a given, here you need to remember certain simple equations, this equation also, and also this equation. Basing on this, you can write any other variables. So you just observe here, what is relation between T and U? Time factor is always depends on the degree of consolidation. You can look at here, T is proportional to U square. Time factor is if the degree of consolidation is less than 60%, time factor is pi by 4 U square. If the degree of consolidation more than 60, time factor is this. Don't remember this formula, but you have to remember this formula for computation of any time factor for a degree of degree less than 60%. So here in this, T is proportional to U square, or otherwise U square is proportional to T. U square is proportional to T. But here it is given for a given soil and drainage condition. Given soil means CV is constant. Given drainage condition means D are also same. Given soil CV is same. Given drainage condition D is same. Then in this CV and D are same. So what is going to happen here? T is proportional to small t. When T is proportional to small t, already T is proportional to U square. So you can also write U square is proportional to T. And U is proportional to root T. U is proportional to root T. And what is U? What is U? U is proportional to S. You can see here, U is proportional to root T. Once you know the U is proportional to root T, U2 by U1 equal to root T2 by root T1. So you can establish this equation. Don't by heart any of the formula, but remember the base formulas. Remember U formula, T formula, and also capital T formula. Basing on these three, you will get all these relations. But if you try to by heart the relations, you will never get correct relation in the exam. So here T is proportional to T. T is proportional to U square. So T is proportional to now U square, and accordingly U2 by U1 equal to T2 by T1 under root. And similarly, what is U? You know U is proportional to S. You can look at here. U is proportional to S because SF is fixed. When U is proportional to S, you can also write U2 plus S2, U1 plus S1. It can also be root of T2 by T1. So all these relations are interrelated, and don't by heart too many number of relations. Then isochrons. Isochrons are the curves which represent the variation of excess hydrostatic pressure with respect to depth. For example, at a particular depth, the excess pore pressure is same at all these different points, and if you draw the curve along passing through the various points, then it is called the isochron. Isochrons are the curves representing the variation of the excess hydrostatic pressure with respect to the depth. So this is another isochron, it is another isochron, it may be another isochron. Several numbers of isochrons may be present. And slope of the isochron, for example, slope of this isochron at this level, this is called the hydraulic gradient. Then degree of consolidation. Already you have seen earlier, U equal to S by SF into 100, and S is always varying from 0 to SF. S is always varying 0 to SF. And consolidation maximum is 0, and so U varies from 0 to 100%. Consolidation varies from 0 to 100%. Then settlement. So here in this entire chapter, okay, I'll come to later. Then settlement. Already you have seen earlier at the beginning, there is initial settlement, primary settlement, and also secondary settlement. And for cohesion soils, there are two soils, cohesive soils and cohesionless soils. For the case of cohesionless soils, this entire consolidation discussion so far is only for the cohesive soils. Is only for the cohesive soils. And for cohesionless soils, some other methods are to be adopted, particularly standard penetration test for predicting the settlement of the soil. And in standard penetration test, SI intermediate settlement equal to, this is the formula, intermediate settlement equal to H by CS into log E sigma naught bar plus delta sigma by sigma naught. And these are the various parameters to be used from the standard penetration test, and read the appropriate values corresponding to the static cone resistance and also the various compressibility constants, and accordingly using SPT immediate settlement can be found. So I will discuss more about standard penetration test in some other chapter. Then for cohesive soils, because we are discussing now cohesive soils, SI equal to immediate settlement. SI means immediate settlement equal to QB into 1 minus mu square by ES. So already you know that the soil is going to be converted into plastic in nature completely, and mu is the coefficient of mu is the Poisson's ratio of the soil. Mu is the Poisson's ratio of the soil, and E is modulus of elasticity of the soil beneath the foundation, and IF is the influence factor. Q is the surcharge load acting on it, and B is the width of the foundation. If some parameters are given basing on this, it is called the elastic foundation, because modulus of elasticity is term involved, Poisson's ratio term involved means the soil which is under elastic in nature. In such a cases, immediate settlement will be equal to this formula. Just remember the formula. In the examination, only substitution of several values for getting the immediate settlement of the soil. And consolidation or primary consolidant, already you have seen SC equal to, already you have seen this equation, and there is no difference. Then last one, secondary settlement or secondary compression. So in the case of secondary compression, the actual pressure transmitted from the foundation to the soil is entirely different, depending upon the different types of soils. So for example, you can look at the center one, sand. Because why we are taking sand means initially or otherwise imagine that you are walking on a sand. You are walking on a sand or river sand where cohesion is zero. Cohesion for the soil is zero. While walking, what are how about your footprints? Your footprint is in such a way that more pressure will be at the center part and less pressure at the outer part of your foot. You can look at here at the adjacent on either ends of your foot. The pressure will be almost zero, and more pressure will be at the center. While walking over the sandy soil, you will get a pain at the middle of the foot. You will get a pain at the middle of the foot. That means large pressure is acting at your middle of the foot. That's why the stress distribution diagram is parabola with zero intensity at the either ends and maximum at the center. Maximum at the center. You just try. Always it is difficult to reproduce the same diagram unless you know some imaginary methods. So while walking on the sand, you will get more pain at the center part of your foot. So that is possible only when there is a high intensity of stress at the center. And at the outer area, there is no stress. Almost stress will be equal to zero. This is the variation of the stress diagram when soils are on sandy soils. And the next one, it is completely clay soil. Completely clay soil. So you can imagine that it is exactly opposite to the sand, or otherwise, imagine that you are keeping your foot on the marshy land, on the marshy land. So what is going to happen? You will get pain at the edges of your foot, and no pain at the middle. While walking while moving in the mud, full mud area, total mud area, where plenty of clay is available, and you will get pain only at the ends and not at the center. Not at the center. So that's why it is very difficult to even to remove your foot from the clay. You put from the clay. So this is the associated pressure diagram for the clay soils. A footing is resting on the clay soil. When the footing is resting on the clay soil, pressure need not be uniform. So minimum intensity of the stress on the soil will be at the middle center, and the maximum is at the outer level. And in case of sandy soils, maximum intensity of the pressure at the center, almost zero intensity of the pressure at the edges. And another type of soil which is called C5. So both will present. So that means at the center also considerable pressure, at the ends also considerable pressure. So it forms a curve like this, and pressure is almost uniform, but it is not uniform. It is in case of C5 soil. So these are the three pressure diagrams when the footings are resting over sandy soils or clay soils or C5 soils. So with this, the entire theory regarding the consolidation chapter is completed. So in total, what is that you need to remember? What is that you need to remember? What are the various formulas? The various formulas are: remember AV, remember MV, remember CC, and also delta H will be equal to H multiplied by delta E by 1 plus E naught. Sorry, delta H will be equal to CC by 1 plus E naught into log of base 10, sigma plus delta sigma divided by sigma. This is a consolidation settlement. And another formula, TV will be equal to CV multiplied by T by T square. One more formula, TV equal to pi by 4 into U square, and U equal to S by SF multiplied by 100. So these are the only formulas required for solving the numerical problems in consolidation. These are not at all difficult. You know that AV will be equal to minus delta E by delta sigma. MV is nothing but minus delta E by delta sigma multiplied by 1 plus E naught, initial volume. What is CC? CC is nothing but delta E divided by log of delta sigma by sigma naught. So these are the very simple formulas that you need to remember in the entire consolidation chapter. Once you understood all these formulas, you can solve any type of problem in consolidation. So let us move to numerical problems that appeared in GATE examination. It's a very recent question, GATE Civil 2020 examination. A 10-meter thick clay layer is resting over 3-meter thick sand layer and is submerged. You can look at a 10-meter clay layer. 10-meter clay layer is resting on 3-meter sand layer. 3-meter sand layer, and it is completely submerged. So the water table is at the top of the clay. A fill of 2-meter thick sand with the unit weight of 20 kilonewton per meter cube is placed above the clay layer to accelerate the rate of consolidation of the clay layer. So what is going to happen in this particular problem? In this problem, it is given that again the 2 meters of sand, thick sand is laid. 2-meter thick sand is laid over the clay for accelerating the consolidation process. The coefficient of consolidation for clay is coefficient of consolidation of clay is C is V is given, and coefficient of volume compressibility means MV, where whenever coefficient of compressibility term is associated with volume, MV is given. Assume Taylor's relation for time factor, average degree of consolidation. What is the Taylor's equation? TV will be equal to C into T by T square. CV, coefficient of consolidation, into T by T square. What is the question? The settlement of the layer in layer 10 years after the construction of fill. So what is the time? Time is given 10 years. After 10 years of placing the sand, how much settlement is there? So what is the value of S? What is the value of S? This is the simple question that you know, and observe the various formulas, because MV is given, CV is given, and basing on this, what are the various parameters to be found for computing the final answer? You can look at next. See the total data that is given. See the total data given. Thickness of the clay layer 10 meters, and the delta sigma. What is delta sigma? Delta sigma is only because of the surcharge load. So initially you can look at water table present, and at that level, whatever the stress at the center of the clay, so you can look at here at the center of the clay, you need to find out all the stresses. That is initial stress and also increase in stress. Because of 2 meters of sand provided over clay, what is delta sigma? Delta sigma equal to 2 multiplied by 20, because its density is also given as 20 kilonewton per meter cube. So delta sigma is now 40 kilonewton per square meter. So that is given here. You can look at 20 into 40. And coefficient of consolidation, it is directly given. Coefficient of volume compressibility also given, and time period of consolidation is given. S is to be found. So this is the question. For that, what are the equations that you know? We know MV H into sigma S. Since MV value you know, delta H is M into H into delta sigma. And what is delta H? What is delta H? Either you can call delta H or SF, which is equal to MV given H is also known, delta sigma also known, it is equal to 88 millimeters. And using Taylor's equation, this is the Taylor's equation, and you know that for the clay, above it is sand, below the clay also it is given as sand, above sand and also below sand. So what is the drainage path? It can be move, water can move above or below, so that it is double drainage. So D will be equal to H by 2, 5 meters because double drainage. And substitute in a TV, you will get 0.036 time factor because CV you know, T you know, and also D square you know. What is that you need to calculate? S value. So here in the previous case, whatever the value of SF, this is ultimate settlement. Final settlement is SF. Final possible settlement. But final possible settlement is basing on MV into H into delta sigma. But what is the actual settlement after 10 years? Actual settlement after 10 years is TV equal to pi by 4 e square that you know. Already TV equal to 0.036 computed just now and U is 0.214. What is U? U equal to S by SF. SF is known 88 and S settlement E will be equal to 18.83. So in all very simple equations, one equation to the other, if you just follow, you will get the settlement. So after 10 years, the settlement of clay layer is 18.83 millimeters. But total settlement is 88 mm. Total settlement may take even thousands of years to get 88 mm of it. So you can look at once again the problem. It is clearly given that clay layer, sand layer, and additional sand layer over the clay so that soil clay can be compacted very quickly. And all other associated properties are given. Basing on the properties, you can find out the total settlement and you can also find out the time factor. Once you know the time factor, you can get the degree of consolidation U. U is called degree of consolidation. Degree of consolidation is S by SF. You can find out S value. So this is a very recent question in the examination. And it is another question appeared in the recent exam only in 2020. In 2020, I'll read the question. A one-dimensional consolidation test, a one-dimensional consolidation test is carried out on standard 19 mm thick clay sample. So what is the thickness of the clay? H equal to 19 millimeters. The odometer deflection gauge indicates a reading of 2.1 mm. So odometer is used for measuring the compression of the soil. So when the deflection gauge deflects and it shows the reading of 2.1 mm means the compression is 2.1 mm. That is delta H. Delta H is 2.1 mm. Just before removal of the load without allowing any swelling. The void ratio E is 0.62 at this stage. The question is the initial void ratio of the standard specimen is. You know the formula delta H by H equal to delta E by 1 plus E naught. Everybody knows about it. Delta H is now 2.1. Total sample height is 19. Delta E means E naught minus E. E naught is the original void ratio. 1 plus E naught here. So in the entire equation, only E naught value is unknown and E naught value 0.82. You can look at it is for 2 marks and how simple the question is. Only thing is you need to understand the overall question and basing on that observe the required related formula. You will get the total solution. Okay, this question also appeared very recently in GATE examination. And one more question in the recent GATE paper. That means two question papers are there for civil. In one question paper, two questions from the same chapter. Two questions from the same chapter. You can look at a footing of size 2 meter by 2 meter. A footing of size 2 meter by 2 meter, transferring a pressure of 200 kilonewton per square meter. So at the footing bottom, the intensity of the pressure is 200 kilonewton per square meter. First understand the question and also diagram carefully. The question look like very big, but the solution is not so that tedious. Is placed at a depth of 1.5 meters below the ground level as shown in figure. You can see bottom of the footing is at a depth of 1.5 meters below the ground level. The clay stratum is normally consolidated. Okay. The clay has specific gravity G 2.65. G 2.65 and compression index 0.3. Cc equal to 0.3. The considering 2:1 vertical to horizontal method of load distribution, what is going to happen here is load is going to distribute 2:1 method. 2:1 method. The load is going to disperse, whatever the load is there, that is going to disperse like this. 2 vertical and 1 horizontal. That means for 2 meter vertical, 1 meter horizontal dispersion will occur. Method of distribution and gamma W 10 kilonewton per meter cube. Kilonewton per meter cube. The question is the primary consolidation settlement is. What is the delta value? Delta H. What is the delta H? What you have to do? In the formula. In the formula, there is a term H. What is the thickness of the layer? Thickness of the layer H will be equal to 1.5. You can see what is the thickness of the clay layer. Okay, look at the diagram. So in this particular diagram, observe the various other parameters. Load is 200 kilonewton per square meter. First sand is silty sand available. Groundwater table is 0.5 meter above the clay and saturated density 18, dry density 15, clay saturated density 17 and clay thickness is 1.5. Clay thickness is 1.5. So here the question is what is delta H? Once the question you understood, this is the formula, write the formula. In this, what is H value? That is known. H is nothing but, you see the last one, 1.5 meters. And what is Cc? It is also known. Cc is nothing but 0.3, it is given along with the problem. And E naught, initial void ratio. Initial void ratio is not given in the problem. What you do? Based on the information, gamma saturated equal to G plus E by 1 plus E gamma W. So in this gamma saturated 17 given for clay, you can look at the diagram, original diagram. At this place, gamma saturated for clay is 17 kilonewton per, you can look at 17 kilonewton per meter cube given. And for gamma saturated, this formula. From this formula, you can compute the initial void ratio E. Initial void ratio E. Okay, in the formula H, Cc, E naught, all these parameters are known. Now find out sigma naught. Is there any initial stress given in the question? No, it is not given. So compute that. Initial stress means initial effective stress. Already effective stress computation in sigma naught, initial effective stress at the middle of the clay layer. So up to the middle of the clay layer, find out the initial stress. What is the stress? First 1.5 meter and also another 0.5 meter is dry. So multiplied by dry density, gamma into H. You can look at gamma into H. Gamma is 15 H is 2 meters. And saturated height is 0.5 meter. 0.5 meter. 0.5 meter is saturated multiplied by saturated unit weight 18 minus 10 plus so up to the center. This distance is 0.75 because total clay is 1.5. So 0.75 into gamma dashed. Gamma dashed means gamma minus gamma saturated minus gamma. So this 39.25 is the initial stress at the center of the clay layer. So in the formula sigma naught is also known. Now what is delta sigma? Delta sigma is the increase in pressure at the center of the clay because of the footing. Increase in the stress at the center of the clay layer because of the footing. What is the stress at the footing bottom? Stress at the footing bottom is stress at the footing bottom is 200 by 200. What is the size of the footing? What is the size of footing? It is nothing but 2 by 2. So what is the load coming from the footing? Load coming from the footing is 200 multiplied by 2 into 2 because 2 into 2 is the area and 200 kilonewton per square meter. But where the stress is required, you require the stress at the middle part. And the load is dispersing 2 is to 1. Load is dispersing 2 is to 1. So what is the height up to the center of the clay layer? Up to the center of the clay layer, the height is 0.5, 0.5 and also 0.75. How much is the distance? 1.75 meters is the vertical height. When 1.75 meters is the vertical height, what is the total width? This be at the center of the clay layer 2 plus 0.75 by 2 plus 0.75 by 2. That is 2 plus to 2 plus or otherwise 2 plus 0.75 0.75 which will be equal to no 2 plus this center is 2 meters whereas this vertical distance this horizontal distance is basing on this 2 is for vertical 1 is for horizontal. What is the total vertical distance? Total vertical distance will be 0.75 0.5 0.5 1.75 not 0.75. So it will be 2 plus 1.75 by 2 1.75 by 2 because this side 1.75 and that side also 1.75. At the center it is 2 meters. So total is 3.75. You can look at here will be width of the dispersion at the middle of the clay layer. Width of the dispersion at the middle of the clay layer is 3.75. And what is the total load? Total load from the footing is 200 into 2 by 2. What is the stress at the clay layer multiplied by divided by 3.75 and 3.75. You can look at here delta sigma equal to increase in stress due to low footing. That is 200 into 2 into 2 by 3.75. 3.75 you will get 56.9. So from this you got every value. Some of the values are given and E naught now found, sigma also found, delta sigma also found. By substituting all these values you will get the delta H value for the given clay layer of soil. It is a 2019 question. 2019 question. It's also a very simple question. You can look at construction of a new building founded on clay soil was completed in January 2010. So building completed in January 2010. In January 2014, that means after 4 years, the average consolidation settlement of the foundation clay was recorded as 10 millimeters. Was recorded as 10 millimeters. That means In 4 years span, the settlement recorded as 10 millimeters. You can look at here. You can look at here. During the time 4 years, the settlement will be equal to 10 millimeters. The ultimate consolidation settlement was estimated in the design as 40 mm. What is SCF? SCF ultimate, that means the maximum possible settlement is 40. Considering double drainage to occur at the clay soil site, the expected consolidation settlement in January 2019 will be. So January 2019 means what is the time from the time in January 2009, time is 2019 minus 2010, because the base period is 2010. So it is 9 years. That means the question here is, in a 4-year span, the settlement S1 equal to 10 mm. After 9 years, what is the settlement S2? That is the question. So in 4 years, settlement is 10 mm. In 9 years, how much is the settlement? That is the question in this particular problem. And here you need not worry about all the several number of equations. You know that same soil, so CV is constant. Same soil, CV is constant. Same drainage condition, D is also constant. So TV is proportional to time. T is proportional to time. And again, what is T? T equal to pi by 4 U square. So TV is proportional to U square. And from these two, TV proportional to T, TV proportional to U square. So you can write T is proportional to U square. And U square. So basing on this or otherwise, T is proportional to U will be equal to S by SF. So that means U is proportional to S. So we can write here T is proportional to S. So you can write T2 by T1 will be equal to U is proportional to S. So T is proportional to U square. So T is proportional to S square. So what you have to write? S2 by S1 whole square. S2 by S1 whole square. So what is the question here? Question is, what is S2? What is T2? Time 9 years. What is T1? 4 years. And S1 10 millimeters. From this, you can find out the value of S2, which is 15 millimeters. That's all. Only thing you need to establish this relation based on the known equations. Once you establish the relation between T and also S, substitute the value and get the final answer. Next question. It is appearing it appeared in 2018. The compression curve void ratio E versus effective stress for a certain clay is a straight line in a semi-logarithmic plot. You know that semi-logarithmic plot is drawn for the purpose of computing the compression index, and it passes through the points E 1.2 50 and E 0.6 800. The compression index is. So you can look at here in the diagram. It is very clear. With the diagram, it is clearly explained. So here 50 means it is log 50. 800 means it is log 800. And you know that Cc equal to delta E by log 10 of sigma dashed by sigma 1. And substitute the values, that will be the compression index from the problem. Compression index of the required value 0.9498, and in the examination up to 2 decimal. So though the value is 0.498, you need to represent only 2 decimals, means either you have to put the answer 0.50 or otherwise 0.49. So these are the two values to be entered for the numerical question. The next one, of course, this will be covered in the next chapter. Seventh question. It is in 2017. Almost every year, questions will be there on consolidation chapter because it's an important chapter. A 3-meter thick clay layer is subjected to an initial uniform pore pressure of 145 kPa as shown in figure. So initial pore pressure U naught equal to 145. Because the expulsion of water from the clay, initially it is under a pressure of 140 చూడండి. ప్రెసెంట్ తీసుకోమంటారా? స్టూడెంట్స్ ఉన్నారా లైవ్ లో? మరి వెళ్ళిపోయింటారేమన్నా? ఓకే, రైట్. ఎంత టైం అయింది పోయి? అంతేనా? ఓకే, రైట్. So now look at this question. This appeared in 2017 GET examination. I'll read the question. Just follow here. A 3-meter thick layer is subjected to an initial uniform pore pressure of 145 kPa. So 145 uniform pore pressure for dissipation of the water from the soil. For a given ground conditions, all conditions are given in the diagram. The time required for 90% consolidation would be. So all properties are now you can see in the diagram. Thickness of the layer is 3 meters, and one side it is impermeable stratum, another side it is sand. So water has to move only from in one direction. So it is called single drainage path. And coefficient of consolidation, time factor also given. With all these parameters, a relation is TV equal to CV into T by D square. So substitute all the values, only T is the unknown value. You will get T in minutes and finally convert it into days. So once you got 1770.8 days, the answer must be rounded off to nearest integer. So you must use either 1770 or 1771 is the correct answer. Now let us move to another problem. The results of a consolidation test on an undisturbed soil sampled at a depth of 10 meter below the ground level are as follows. Saturated unit weight 16, pre-consolidation pressure 90 kilopascals. So pre-consolidation pressure means the pressure existing on the soil. Already soil is under pressure, that is called the pre-consolidation pressure. The water table was encountered at a ground level. Assume the unit weight of soil 10 kilonewton per meter cube. The over consolidation ratio of the soil is. So you need to find out over consolidation ratio, OCR. So you know already OCR means it is nothing but stress in the history divided by the existing stress. So what is the stress in the history? Stress in the history pre-consolidator pressure means already pressure is acted on the soil is 90 kPa. 90 kPa. So that you can see at the end, OCR equal to already pressure in the stress history is 90 divided by present stress or existing stress. What is the stress at the existing level? You know that the sample is taken from 10 meters below the ground level and water is up to the ground level. So sigma dash will be equal to gamma dash H. What is the gamma dash? Gamma dash is already gamma dash into H. Gamma dash means H is 10 meters. Gamma dash is 16 minus saturated unit weight is 16. So 16 minus 10, it is 6. So 60. So 90 by 60 is the over consolidation ratio. So here only thing you need to understand the meaning of over consolidation ratio. Over consolidation ratio means the stress in the history or pre-consolidation pressure divided by existing pressure on the soil. So stress history on the soil divided by existing stress on the soil is called the over consolidation ratio, and it is 1.5. Now let us look another problem. It looks like a big problem, but do not worry at any time and always observe the clear procedure. You will get everything. An undisturbed soil sample was taken from the middle of the clay layer. You can look at clay layer is 1 meter thickness, sand layer is also 1 meter thickness, and below clay hard stratum. It means that one side hard stratum, another side of clay is sand. It is only single drainage path. The water table was at the top of the clay layer. So you can see groundwater table is at the top of the clay layer. The laboratory test results are as follows. Natural water content W, pre-consolidation pressure of clay 60, already pressure existing on the soil is 60 kPa, compression index Cc 0.5, recompression index 0.05, specific gravity, bulk unit weight, and compacted fill of 2.5 meter height with the unit weight of 20 kilonewton per meter is placed at the ground level. So what is going to happen here is for accelerating the consolidation, 20 kilonewton per meter cubed unit weight of sand or fill is provided for a height of 2.5 meters. It is provided for 2.5 meters. That means pressure at the center of the clay layer is because of the fill provided above the sand. Fill provided above the sand. Then assume the unit weight 10, ultimate consolidation settlement is. So here the important thing you need to remember is pre-consolidation pressure is given and you need to compare that with the other parameters that I will tell you in the next page. So you can look at the diagram given, 2.5 meters fill is now provided with a density of 20 and 1 meter sand, 1 meter clay. And all the details are given in the clay. You need to find out all the stresses exactly at the center of the clay. So you do not know the gamma saturated for clay. Since gamma saturated for clay is not known, find out gamma saturated. To know the gamma saturated, S is equal to Wg by E. Here water content is given. It is since it is completely saturated, S is 1. Accordingly, E value is 0.675. Substitute that in gamma saturated, you will get saturated unit weight of the clay is known. And at the middle of the clay layer, what is the initial stress? Initial stress is because of the sand. What is because of sand? Initial stress because of the sand is 1 meter. So 17 into 1. Gamma into H. And in the clay layer, because it is up to the middle of the clay layer, it is 0.5 meters. So gamma saturated minus gamma multiplied by 0.5 meters. So this is the initial pressure. And because of the load provided, fill is provided above the sand, you will get delta H. Delta H is because of the gamma 20 multiplied by 2.5. You can write 2.5 multiplied by 20. It is 50 kilonewton per square meter per meter cube. But this is the additional pressure. Additional pressure is 50. But what is the original pre-compressed pressure that is given in the problem as 60? That is given in the problem 60. That means already the soil is under more pressure than the existing. So that's why here a small thing is to be found. Sigma effective is sigma naught plus change in value. The total is 72. So what you have to do in this particular case is particularly since the soil is under pre-consolidation, we have to compute the settlement because of the pre-consolidation and also the existing fill over the soil. So that's why here it is pre-consolidated to initial and pre-consolidated to final. So this S is now divided into two different terms. This is one term and this is another term. So first term is the term in which the pressure is varying from initial stage to sigma naught to pre-consolidated pressure sigma p, and final one is sigma pressure to sigma dash. So two different equations are to be used for computing the ultimate settlement. So that's why here initial is 22, pre-consolidated 60. Here starting is now pre-consolidated and final is 72, and sum of these two you will get 37.6 millimeter is the total settlement of the soil. Now look at this diagram, this question. It is also computing the delta H only. You can calculate later. And this is one more problem, which is in 2015. A 20-meter thick clay layer is sandwiched between silty sand and a gravelly sand layer. So that means here it is given clay layer is sandwiched between sand layer on one side and another side is gravel. So that means through both of these two on either side water can pass. So the clay is under double drainage condition. Double drainage condition. The layer experiences 30 mm settlement in 2 years. So H equal to 20 meters, T equal to 2 years, and other parameters TV in equation is given, where TV is the time factor, U is the degree of consolidation. If the coefficient of consolidation of the layer is 0.003 square centimeter per second, the deposit will experience total 50 mm settlement in how many years? In how many years? So here the question is, in 2 years, the settlement is 30 mm. In 2 years, settlement is 30 mm. In how many years the settlement equal to 50 millimeters? And for that, for computation of time factor TV, the values are given. If the degree of consolidation is less than 60%, everybody knows that it is 5 by 4 U by 100 whole square. If the degree of consolidation is more, because it is difficult to remember, so that's why the formula also given along with the question. And already I told you this is a double drainage and D equal to 10 meters. Using this formula TV, CVT by D square, you will get 0.189. Once it is 0.189, you can find out TV value. U square, TV equal to 5 by 4 U square. So U equal to 0.49. What is that 0.49? 0.49 means 49% is the degree of consolidation. Since the degree of consolidation is less than 60%, this formula is okay. So what is the total settlement? Total settlement is SF equal to 30 by 0.49. What is this 30? This 30 is the settlement. It is nothing but U is equal to S by SF into 100. U equal to SF by S by SF. Here SF value is known. Here SF is not known. S is known 30 meters, 30 millimeters, and TV U is also known. You can find out SF, which is equal to 61.22 millimeters. 61.22. Then next, degree of consolidation for 50 mm settlement. So what is the final settlement? Final settlement is 61, but your settlement required is 50. So accordingly 81.7 is the degree of consolidation. When degree of consolidation is 87%, You do not know the formula, but the formula given in the exam question paper. U is greater than 60. Accordingly, the formula is given TV equal to 1.74 into this. Substitute and get the value of TV. Knowing TV value, find out T by substituting all other parameters, and it will be 6.41 years. 6.41 years. So in the question, you need to understand the question. Here, what is question? The deposit will experience a total of 50 in the next dash years. In the next dash years means already 2 years over. In the next, that means time after 2 years. That means the final answer must be not 6.41. It is 6.41 minus 2 years, which is equal to 4.41 years. So like this, several other problems with the same concepts are given, everything, because in this problem also delta H is to be computed and a clear cut procedure is given. Like that, several other problems also I am going to provide you the entire thing, and go through all these problems. And if you have any doubts, you can mail doubts, so that in the next class I will cover this first, or otherwise I will send information or answer through your mail. So you can note down my mail ID. You can note down my mail ID, and you can send all the doubts also, and also the questions to the mail ID pjrgate @gmail.com. This is created only for this purpose, because if I open this mail, all questions or the doubts from various students, so I can answer easily. So remember this once again, pjrgate@gmail.com. You can send any questions or doubts to that mail. I will answer appropriately. If required, I will explain the same for the benefit of all the students. Or if your question is particular for limited, I will send the answer through email. Okay, with this the consolidation chapter is over. I will send the material, entire theory, and also all solved problems of gate examination, previous years gate examination, and go through each and every concept. And any doubt arises, immediately you can give information through my mail pjrgate@gmail.com. Okay. Thank you, one and all. Thank you very much.